Good morning and welcome to our 18th annual exhibit of hydrogen and fuel cell technology. We've been here since 1995 talking about this very innovative technology. I'd like to welcome all of the guests here and invite them to sit down. We are serving free beverages, so there's coffee, tea, all sorts of fruit juices and cola, whatever your heart desires, and listen to some interesting facts and information about the fuel cell industry here at the Hanover Fair. Our next guest on the stage is Managing Director at Gardner Denver, and his name is Herbert Mansell. Please welcome with me Herbert Mansell.
Hello. Hello, nice to meet you.
Good morning, Herbert.
Good morning, Brian.
So, I've been over to your booth and I was looking at the technology. Perhaps we could start, if you could tell us a little bit about Gardner Denver. What does it do? What do you do?
Yeah, so actually we are a brand of Gardner Denver, and the brand means we are the Thomas division, which is a big part of Gardner Denver, and we are concentrating on the OEM business. We produce compressors, vacuum pumps, liquid pumps, for different applications, different markets, and all what we do is oil-free technology.
Mm-hmm. So you're the pump specialist largely?
Yes, we are.
Mm-hmm. What type of industries do you service? I can imagine there are specific pumps, there's water pumps, do you have a specific market focus? Do you cover intensively some markets but sort of do very little in other markets, or do you do pumps across the board?
Yes, so we do concentrate more or less on the so-called ELM markets, which is environmental, which is medical, and which is laboratory, These are the three markets. And we are very experienced in the medical field, we serve since a long time, various of pumps for many different applications, just to give you an example, this is the smallest pump we have, and we supply this to a manufacturer of anesthesia gas control.
So you're the guys who keep people living on the machines. It's very comforting to know I've got connections with this technology here. The medical industry, does that make up a large portion of your entire sales? What sort of percentage would you be talking about for the medical industry?
So I would say it's worldwide around 30% of our turnover. This is made in the medical applications area. And within this technology, we need a lot of experience, and all the products we manufacture for this part have to be very reliable.
Mm-hmm. Yeah, these are not pumps like if my water pump at my cottage breaks down, well, I have to fix it. But it's certainly critical if something in the medical industry malfunctions. I can imagine that there are other issues that are similar to the fuel cell issues. Before we get to that question of how you jumped into the fuel cell industry, what sort of demands do you face? I know that hospitals, they're fussy about hygiene, they're fussy about... And they have to be.
So in the medical industry, actually, oil-free technology is required. And so we have a lot of experience in producing oil-free technology, oil-free products. And when it came up with these applications in the fuel cell area, we thought our product program would fit perfectly to this market. And so with some adaptations, modifications, we can solve many applications within the fuel cell area.
I find the networking potential within communities so fascinating when someone discovers, wow, they've got the skills exactly that one needs, perhaps with a little bit of modification for another industry. When we were preparing for this interview, you told me a wonderful story about how you looked for a student. You were thinking, we want a future market, let's go and search for it. Could you tell that story again?
So when it came up with these ideas for the fuel cell area, we had the idea to hire a student to do his master's degree. And we had him educated for a couple of months, yeah, and he found out the requirements, the basic requirements, yeah, on fuel cells, and he found out also the basic pumps, yeah, which would fit for some of these applications.
Mm-hmm.
And so the results encouraged us actually to proceed doing more and more efforts to get a portion of this market.
Mm-hmm. I find that fast. Hire a student. It's a student job, and it's a way to finance education.
Yeah.
So let's. You already noted. Okay, we do have pumps that are specifically useful for the hydrogen fuel cell industry. I suppose I have two questions there. One is, if you discover, okay, they could use our pumps, you also have to consider, is it worthwhile getting involved? So at what point did you make a decision to say, oh, let's actually invest some time and energy and find out how much business we can do with the fuel cell industry? Was there a strategic decision there at some point?
I think it is more or less a strategic decision, yeah, because it is definitely a future technology. We believe that it will be some of these things, which will drive the energy in the future. Mm-hmm. And it was clearly a strategic decision, and for this reason, we also do single samplings, and we do a lot of efforts, to fulfill the customers' or the potential customers' requirements. Mm-hmm. Yeah.
Now, beyond that strategic decision, when you got involved, what type of technology was it? We have, of course, a selection of various fuel cells on the market. Mm-hmm. Many of them do require very specific pumps to keep the things running. Mm-hmm. What type of fuel cells do you work with?
At present, we concentrate on the H2, HT, PAM. Mm-hmm. The PAM, the SOFC, and the DMFC, these are the typical fuel cell applications, mm-hmm. Where we supply pumps for these various applications, so like, let's say, within the DMFC we have the dosing of the methanol water, the recirculation, we have primary air supply, and for the PAM we have providing the gas, or we have H2 recirculation, we have primary air supply, and sometimes we have condensate removal, we have cooling applications, so we need various types of technologies and types of pumps to solve all these requirements within the fuel cell types, different types. Mm-hmm.
One recalls when one was in university or high school in the physics class, they demonstrate a PEM cell. It looks very simple because the small models are. You have hydrogen coming in. You have a membrane in the middle of it, and out comes electricity, and it all looks very simple. When you build a stack, though, what I've learned is that there's a whole complicated process surrounding the stack, conditioning, keeping it moist, making sure that flows are measured, and so on. So it is a complicated business. Here is my question. There have been fuel cells for considerable time. With all of that infrastructure around it, with your pumps, what changes? There's so many different pumps on the market. I know the pump with a typical electrical motor. There are DC brushless motors. What is the specific change in design of your pump that does something different?
Actually, the design, the change, was caused by other reasons. But we recognize clearly that there is a specific design which can fulfill specific requirements within the H2 applications. For instance, we found out for the primary air supply, it's very positive to use a so-called linear diaphragm pump, because we can influence both things. We can influence the amplitude and we can influence the flow, and this means with these two criteria we can adjust the pump exactly to what the customer wants to, and especially we have designed a new linear pump, yeah, which provides between 30 and 50 liters a minute. And what is very interesting, yeah, the 30-liter pump has a consumption of only 5 watts, yeah, which is really low. And the other positive thing is we have now achieved a lifetime of 40,000 hours, yeah, for this device. Yeah. It's a linear-driven thing, and it does not contain any bearings. Yeah, so it means no wear. Yeah, the bearings are actually the diaphragms. Yeah. So there's no friction, and so this means the power consumption is very low compared to all other systems. Yeah.
When you say 40,000 hours, what is the typical lifespan of a car these days?
Yeah, so BMW is testing for 2,500 hours, yeah, and if you go for 350,000 kilometers, then let's say 4,000 hours, yeah, means this time this pump lasts 10 times longer, yeah, than any car, yeah, which is on the market. Yeah.
And just to add to that, I find when you compare the statistics of the duration of a fuel cell, is there any fuel cell that is getting beyond 20,000 hours?
At present, I cannot see any fuel cell technology which provides a lifetime longer than 40,000 hours. Yeah. These are the typical requirements. In some cases, the requirements are far lower, so the expectations are 4,000 to 5,000 hours. It depends always on the type of fuel cell. Yeah. But for these types, let's say for the SFC, yeah, we have high expectations on the lifetime, and so we typically think about the 40,000 hours at present.
One of the critical questions when you're supplying infrastructure to a fuel cell stack, by that I mean all of the circulation of the gases and the airs and so on, one critical question is reliability, not simply in how long the device lasts, but in actually creating the precise flow. When one considers that the stack is often the most expensive thing, if you're building an automobile and running it on a PEM cell, there are all sorts of precious metals in there. There's platinum. There's a variety of actually precious metals in there. And these things are very sensitive to CO poisoning, any bit of sulfur that gets in there. But it really has to be reliable as well. So if you took your device, I suppose an alternative would be a DC brushless motor. Is there more accuracy as well? Is there any sort of spin-off benefit? What is exactly the advantage besides this ability to adjust the pressure and the flow?
Yeah, so actually both systems are controlled in a different way. As I said before, this device, which is the linear one, can be controlled with the voltage as well as with the frequency. Means we can work on both parameters. This, for instance, is a pump. This is a diaphragm pump. It's a brushless DC. Provides typically 20,000 hours of lifetime. This one, but you cannot adjust the stroke during the running or the operating process. So you can only control this pump with the speed. So the pressure or the vacuum, in this case, the pressure always remains the same. It can be controlled, but I think this system is much more flexible. Especially in terms of the application of primary air supply.
It sounds ingenious to me. When you now you are involved in the fuel cell market, so obviously you have contact with the manufacturers of fuel cells, the designers, the system integrators, and so on. What role do you play there? Do you also get involved in developmental projects? Do you like to have fuel cell manufacturers come to you with specific problems? Is there cooperation there? Or do you basically send them a catalog? How do you work with the fuel cell industry?
So we always have both sides. One side is we actually also do acquisition because we want to generate or enlarge our business. The other thing is we get very concrete inquiries. We get specifications and and we try to solve the specifications. So it's always going both ways.
I should add that if anyone from the audience has a question, they're welcome to raise their hand and we'll deal with them as much as we can. Certainly, what fascinates me, you mentioned the strategic decision. That is, we're always thrilled in the fuel cell industry when larger players, your company is large by comparison with many fuel cell manufacturers, when larger players get involved. To get an idea of the size, how many pumps do you manufacture a year?
Yeah, so I think the last year's number was in total, including the manufacturing facilities in the US and in Germany and in China, the number was 2.4 million pumps a year. Yeah, and so at present is the fuel cell, is not a high number. Yeah, we generate some business, but at present it doesn't pay back.
It doesn't pay back.
Yeah.
So this is for me the interesting thing. What this means is we have a large business, a profitable business that's doing well, that still makes the decision, just a minute, we have something to offer this industry. Is this really because you believe the technology has a future?
Yes, this is, so we had long times, I think we got a little bit hopeless, because there was no movement, but I would say in the past year or in the past 2 years, we could see so many efforts of many companies, to make progress in different areas of fuel cells that I believe this will drive our energy in future, in a smaller parts as well as with huge fuel cells.
Are you involved in any commercial applications? We know that there are some devices marketed right now that actually, without subsidies, they've found a market. Sometimes they're rather niche markets. They're smaller, materials handling or remote power supplies. But are you already involved in commercial typed projects?
Commercial types of projects, yes, we are involved. These are direct inquiries from the industry, from some manufacturers, and we give them prototypes. We are within the testing stage here. We do give recommendations, and we have teams from engineering to engineering, to come together exactly with the requirements and what we can do to fulfill the requirements.
You've been involved for quite some time. Actually, I didn't date your original moment. When did you first get involved in the fuel cell industry? What year was it when you made that strategic decision?
I think it's 15 years ago.
So this is, for a young industry, that is a long time.
It's a long time, and so sometimes the patience is a little bit a problem, but I think sometimes it will pay back also for us, and we will not stop our efforts in proceeding in this market.
I should ask, what is the next step then? We're hoping, of course, you're coming back next year. What do you expect when you look into that broad horizon called the future? What do you think is coming next?
At present I see Japan. There is some success in the 750 watts fuel cells. There are applications for the burner blower as well as for the primary air supply. And so I have seen this yesterday. I have heard the discussions from other players here in this area. And I think we will start with pilot series, and hopefully, let's say 2, 3, 5 years, it will become a mass production or a series production, especially in the field of residential heatings.
I suppose on a final note, you mentioned Japan, the successes there. There are some interesting markets with specific national characteristics that seem to do better. And you mentioned the fate of units that could be installed in one's home, producing energy there. do you anticipate any political decisions that may help the industry? For example, there has been a decision, solar fuel cell owners, they can actually put the energy back into the grid at a price that makes it viable. No such decision has been made to date for people using PEM cells in their basements to create their own heat and their own electricity. Do you anticipate perhaps, or can you imagine any changes that would aid the industry there and also the environment?
Yeah, this can happen with many different influences. Yeah, so when we go back to Japan, we have heard what happened with Fukushima, and this was the really driver, for the fuel cells, because we have these competing energy suppliers. One is gas, one is electricity, and now the gas suppliers try to provide electricity with the fuel cells. This is one of the things which can happen. The other thing is energy in general, fuel cell prices, fuel prices, and things like that. So there are many things around, and you cannot clearly identify what it will be, but it will always be a summary of altogether.
Yeah. Well, with you, I'm looking forward to the future. It's been a pleasure talking to you. Herbert Hansel is Managing Director at Gardner Denver. His booth is E56, just off in that direction. Please visit him there and continue the conversation. We're thrilled to have such large players in other industries come and visit us and contribute so much. So thank you very much for your contribution.
Thank you, Brian. Okay.
And thank you. I'd like to remind you we'll be continuing in exactly 30 seconds. Dr. Joachim Wolf from Hessen's Hydrogen and Fuel Cell Initiative will be up on stage again to talk to us about hydrogen fueling stations and fuel cell forklifts. Be prepared for some interesting facts and information. Thank you for your attention. I'm going to steal my glass of water.